Pictures on 3D cups have depth and appear to move, depending on the angle you view them. It's a neat trick made possible by a technology known as lenticular printing. A sheet of tiny plastic lenses is applied to interlaced images, creating a kind of graphic magic to entertain you. A 3D cup fools the eye. Viewed from different angles, the artwork seems to come to life. It's all a carefully crafted illusion. Making 3D cups starts with clear plastic pellets. An extruder machine melts the pellets to a semi-liquid consistency. An engraving cylinder forms it into rows of tiny convex lenses. Water-chilled cylinders cool the sheet of lenses. This solidifies the plastic. Then a gauge measures the lens's thickness. A blower device dissipates static. An inkjet printer prints information on the edge. This indicates the optical resolution of the lenses, the type of plastic, and the lot number. Then, a rotary blade cuts the plastic into sheets. The sheets land in a neat stack. To confirm their size and alignment, an inspector views them against a pitch test pattern. Another inspector magnifies a sample 100 times and measures the thickness of the lenses. Too thin or thick, and the lens display won't focus. With a lens strip clamped at both ends, the machine pulls it from the top. How far it stretches until it breaks is a measure of its strength. Meanwhile, a team designs and edits scenes on a computer. Designers copy the scene, divide it into very narrow strips, and then interlace the strips. Next, the strips are combined into a two-dimensional digital file. Designers now run test copies known as proofs. This process tests sheets of colored plastic film which will serve as ink. The technician layers the colored film in a cartridge with muslin paper. Next, the cartridge is placed in the printer which creates the proofs. The designer transfers them to an illuminated work surface and confirms that the images line up with the plastic lenses. Once the print plates are made, an operator loads them into the printer. A suctioning arm feeds the lenticular plastic sheets into the printer reverse side up. In this position, the images will be printed on the smooth side of the plastic. Rotating cylinders transfer ink from the printing plates to the sheets, one color at a time. This system prints several different 3D cup images on each lenticular plastic sheet. The press ejects and stacks the printed sheets. The 3D printed sheets now head into a laminator. It applies a white film to the artwork. This film will protect the 3D images during the cup molding process. Next, the sheets are cut into cup-sized labels, placed on an illuminated table, and inspected for any visual flaws. Once approved, the designer clears the labels to be formed to plastic cups. Next, an operator loads the stacks of 3D labels into the cup forming machine. This machine will process 4 different labels onto cups at once, each with a different 3D image. A robot with suction grippers picks up the labels one at a time and transfers them to cup-shaped mandrels. The mandrel inserts the 3D label into the mold of a cup. Molten polypropylene flows into the mold, and as it solidifies and becomes a cup, the 3D label fuses to it together. Robots retrieve the 3D cups and stack them on their sides to await final inspection. Then they're packaged for shipment. 3D cups are no ordinary beverage container. Rather, they're a fun visual experience for any type of consumer.